This video covers Notes 11-2, Rules of Exponents, Day 2. Problems 1 and 2 ask me to expand each expression. So remember yesterday we talked about you have things called bases, and they are raised to an exponent. And what this really means is the exponent is telling you how many times to write the base. So x cubed is x times x times x. It's x times itself 3 times. Now this problem is wanting me to write what's in parentheses, x times itself 3 times, 5 times. So there's 1, 2, 3, 4, 5. So x cubed, just to remind yourself, is x times x times x, and we wrote it out 5 times. Now looking at this line, not this part, how many x's do we see? Well, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 x's times itself. So x times itself 15 times is what we really have on that problem. Now for problem 2, we have 2g times itself 4 times. And they want me to write that 3 times. So you go ahead and start writing it. I'm going to cheat a little bit. All right. So we really have 2 times 2 times 2, which is 8. If you're not sure, put it in the calculator. And then remember, like we said yesterday, we're adding up all of our exponents. We're seeing how many we have. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have g to the 12. Now, I don't know about you, but personally, I don't want to keep writing all of these things out 15 times and 12 times. There's going to be some where you have like a 31 power. I personally am not a fan of writing things repeatedly if I don't have to. So let's see if we can develop a rule. Here, we started with 3 and 5, and we ended up with 15. Okay, On 2, we started with 4 and 3, and we ended up with 12. So if you're not seeing it, what we did was we multiplied those exponents to get our total exponents. 3 times 5 is 15. 4 times 3 is 12. So that could be a shortcut for us. So power to a power, we keep the base the same and multiply the exponents. Or stamp it out and add your powers. This should say add. Okay, so you either keep your bases the same and multiply the exponents, or you write it out however many times and add the powers like we did yesterday. Okay, so think of this as like piggyback riding. N wants a piggyback ride on M, so they take a piggyback ride together. They're right on top of each other. So if they are right on top of each other, we multiply them. Even if they are shown with the operation of multiplication, we add them. So don't get confused on that. So for problem 3, 2 and 4 are piggybacked right on top of each other. So to simplify, 2 times 4 is 8, and we are done. For problem 3, you have to distribute the powers. So everything gets a 2. 2 gets a little 2, and a to the 2/3 gets a little 2. Now 2 squared we can put into our calculator and see that that's 4. And then these are right on top of each other, so we multiply them. You can multiply them in your calculator and get 4/3. We do leave exponents as fractions. Okay, so do be careful there. You have to like backwards distribute if you have more than one thing in the parentheses. So problem 5, this is being piggybacked. So 4 times 2 is 8. And these are being piggybacked. 2 times 3 is 6. Now notice, these are not being piggybacked. They are not right next to each other. 8 and 6 are separated by a multiplication sign and another letter. These look different than these. If you notice, the 2 and 3 I can underline at the same time together, and the only thing I'm going through is a parentheses. The 8 and the 6, I had to pick up my pencil and underline the 8, pick it up and underline the 6. I cannot underline them together without going through a letter. This means it is not multiplication. This means it is what we did yesterday. Yesterday, if they were separated, we added them. So 8 plus 6 is a total of 14. Now again, if you're struggling with this and you want to write it out, write f to the 4 2 times. And write f squared 3 times. And then just add up how many you have. Here we have 8, here we have 16, we have 14 total. So again, if you're not catching the rule, you can break it down and write them out. You're just going to have to write them out a lot. So on 6, I'm going to get rid of these parentheses by distributing. Negative 2 gets a 3, and t cubed gets a 3. Note that it is not t gets a 3 and 3 gets a 3. T cubed is all one term. It all goes with the letter t, and that whole thing is being cubed. Now, 4t squared stays exactly where it is for now. So 4t squared is not changing because I don't have any parentheses or anything I need to simplify. Negative 2 cubed goes in my calculator, and I make sure that I put negative 2 in parentheses. If I do not, it will tell me the wrong answer, and I get negative 8. These are being piggybacked, so 3 times 3 is 9. Now this is like a problem we did yesterday. Multiply your big, add your small. If it helps, write it out like this to where you write all of the pieces separately. So notice, to get rid of the parentheses, I distributed that power of a 3. It's like backwards distributing. Once I get here, this is what we did yesterday. When you multiply big, add small. So negative 8 times 4 is negative 32. T to the 2 plus 9 is 11. So negative 32 t to the 11. On the back, we have some more distributing. Remember, if you have a distributing with parentheses in the back, whatever is around it, everything gets it. So 6 gets squared, m gets squared, n gets squared. Here, these are piggybacked, so m is 9 times 3, which is 27. Now, I don't have my final answer yet because I have letters that are repeated, so I need to simplify those. I also need to figure out what 6 squared is. So in my calculator, 6 squared is 36. I add these exponents because they are separated. I do not multiply them, I add them. 27 plus 2 is 29. N squared stays the same. So again, make sure you see the difference between when you need to multiply versus when you need to add. When they are multiplied, they are right on top of each other like a piggyback ride. When they are separated, like m squared over here and m to the 27 over here, we add. Problem 8, I'm going to take this in 2 parts. First thing I'm going to do is get rid of the parentheses on the top and distribute that cubed to every piece. So 3 gets cubed, a squared gets cubed, b gets cubed. Okay, so when I simplify that out, 3 cubed is 27. These are right on top of each other, so I multiply. 2 times 3 is 6, and then b cubed. And then I leave 3ab, oh, excuse me. Excuse me. I leave the 3ab to the 1/2 completely exactly like it is because I haven't done anything with it yet. So to recap, so far, all I've done was get rid of the parentheses on the top. 3a squared b cubed turns into 27a to the 6b cubed when you distribute that cubed to all 3 parts. From here, we are dividing like we did yesterday. When we divide, we treat the big numbers like normal, and we subtract the little numbers. Remember that wherever the biggest exponent is for each letter is where we leave our answer once we subtract them. So 27 divided by 3 is 9. A to the 6 minus 1 is 5. B to the 3 minus 1/2 is 2.5, which is the same as 5 halves. So put my answer all together. A stays on the top, B stays on the top, 9 stays on the top. Okay. Now 9 has a lot of moving pieces, so I'm going to take it one step at a time so you can see exactly what I'm doing. The first thing I'm going to do is distribute this cubed. Okay, so 5 gets cubed, x cubed gets cubed, z gets cubed. So everything gets a 3. 5 cubed is 125. These are right next to each other. I'm sorry. Let me double check 5 cubed. Yeah, I was right. Okay. X to the 3 times 3 is 9. Z is cubed. I'm then going to distribute this cubed. So x to the 4th gets cubed, y to the 6th gets cubed, z squared gets cubed. So everything gets a cubed. All of these are piggybacked, meaning all of them are going to be multiplied. So x to the 7, I'm sorry, that's not multiplied. X to the 12, y to the 18, z to the 6. Okay, so I'm going to replace what I have so far. So anything in black stayed the same from the original problem. Anything in blue or red is getting replaced. So I'm replacing this 125 with the blue up here and the x12 starting with the red down here. I haven't done anything with the 4x5, y negative 2, or the 10. Okay. Now what I'm going to do is Now what I'm going to do is simplify the top and the bottom. On the top, I'm multiplying. So 4 times 125 is 500. For my x's, I have a 5 and a 9. They are separated, so I add them. I have a y over here and no other y's to mix it with. And I have a z here with no other z's to mix it with. On the bottom, 10 times all of that, we'll just put a 10 in front and leave my exponents the same. My last step is going to be to simplify by dividing. So 500 divided by 10 is 50. I have x's on the top and the bottom. 14 is bigger on the top. So 14 minus 12 is 2. For my y's, I have 18 and negative 2. 18 is bigger and it's on the bottom, so I'm going to subtract. Watch carefully. I have 18 minus negative 2. So 18 minus negative 2 is 20. And that all goes on the bottom. And then z to the 6th is bigger than z cubed. 6 minus 3 is 3. So z cubed goes on the bottom. So this one has a lot of moving pieces. So make sure if you see ones like this that you take it nice and slow. Problem 10, I'm going to get rid of these parentheses on the bottom. So 8 gets cubed, j to the 4th gets cubed, k to the 9th gets cubed. Everything is getting a cubed. Remember, it's basically every letter, whatever exponent was already there is staying, and then you just put the cubed on the outside. So 8 cubed is 8 caret 3, so 512. These are piggybacked, so we multiply. Piggybacked, so we multiply. And I'm going to replace this with a bottom. I haven't done anything with the top. Now with the top, I'm going to divide. Note, the same idea applies. 512 is bigger than 12. So when you do 12 divided by 512, you get something ugly. Math, enter, enter. We get 3 over 128. 128 goes where the 512 is. So 3 over 128. And then if we have a top for our exponents, this will be the top. If we have a bottom, this will be the bottom. So we're starting that fraction already. Now with my j's, 12 is bigger than 7. K's, 27 is bigger than 3. Remember, we subtract, so 12 minus 7 is 5. And it goes on the bottom because that's where I had more. K to the 27 minus 3 is 24. And they go on the bottom because that's where I had more to start from my original. The last problem asks us to find the volume of a cube that has a side length of 3x cubed. So the volume is side cubed. So our side length is 3x cubed, and we're going to cube that. So we distribute the cubed. So 3 gets cubed, x cubed gets cubed. 3 cubed in the calculator is 27. 3 times 3 is 9. So my volume is 27, x to the 9. So today we're adding in the power to a power, or a piggyback rule, and then following the exact same multiplication and addition rules as yesterday, or from 11.1.